So in this video, I'll go through the significant figures worksheet and show how the answers for the different problems were achieved. So I'll do an example for each section, and there are 4 sections in this worksheet. So I'll simply work problem A from each section and explain how to achieve that answer. So for the first part, you're looking at a list of numbers and you're asked to indicate the number of significant figures in each. So I'm just going to rewrite the number just to make it easier to see. So for the first one, we have 17.00. So of course, when we're trying to determine the number of significant figures, we already know that non-zero digits, so anything 1 through 9, we know that those are significant. And so we know that for sure. We know this number has at least 2 significant figures, but where it gets tricky at is when you have zeros present. What I would recommend, when you look at your number, look to see if you have a decimal. In this case, we do. We have a decimal. So once you've determined that your number has a decimal, start at the far left of the number, the very first non-zero digit that you encounter. From that point on, everything will be significant. So in this case, the very first digit was non-zero, which was a 1. So from that point on, so from that 1 on, everything is going to be significant. So therefore, these zeros here are significant. This number contains a total of 4 significant figures because it has a decimal and these zeros are to the right of non-zero numbers. Now, one thing that I do want to point out, just because the zeros are to the right of a decimal does not mean that they will always be significant. They must be to the right of a non-zero digit, which is significant, and the number must have a decimal in order for them to be significant. And so the second part, you have different values and you're asked to round them to 3 significant figures. So again, I'm just going to rewrite the number. So for part A, you have 6,892. What I would recommend when you're trying to round to a certain number of digits, figure out what place that would represent. And so you learned about places way back when, ones, tens, so on and so forth. And so if you look at the number 6,892, figure out the position of your third significant figure. So we have our 6, that's significant. 8 is significant. 9 represents the place of the third significant figure. This also corresponds with the tens position. And so just imagine that you were rounding this number to the nearest 10. So instead of focusing on, okay, I need to round to 3 significant figures, the 3 significant figures corresponds with the tens place, so just imagine rounding it to the nearest tens. This is something that you're probably very familiar with. So if you had 6,892 and you had to round it to the nearest 10, you have to look at that very next digit to determine whether your tens place remains the same or rounds up. In this case, the next digit is a 2, so that tens place, that value remains the same. But what you don't want to do is simply write 689. These are not the same. When you're rounding, you still need to keep the same value. And so rounding to the nearest 10 will cause a 0 in the place of your ones position. And so we still have to keep the value the same. And so 6,892 would round to 6,890 to now have 3 significant figures. So you always want to make sure that when you're rounding, you're still obtaining the value of that original number. Then the next one. Now you have a number, 876, and you're asked to show it in scientific notation with the indicated number of significant figures. So you want to first look at 686, and you can see that this number has 3 significant figures. So we can see that because we're only dealing with non-zero digits. So we know the 8, the 7, and the 6 are all significant. So we can do the same thing we did in the previous section. Since we need 2 significant figures, imagine rounding to 2 significant figures. So this is our first place. This is our second place, which again represents the tens place. So we're rounding to the nearest 10. We can look at that next digit to determine whether or not our tens position remains the same or rounds up. So based on that, there's 6. This 7 will have to round up to give us 880. So this now contains two significant figures, but right now I'm showing the standard notation, and I need the number in scientific notation. So remember, scientific notation, you have a coefficient times 10 to some power. So the coefficient represents only your significant figures, and it represents a number from 1 to less than 10. So in other words, you have a non-zero digit followed by a decimal, and then however many other numbers or digits are needed. So in this case, our very first non-zero digit is an 8. So because the decimal always goes at the very first digit, we have 8 point something. We only need two significant figures, so we should only show two digits in our coefficient, which will be both of the 8s. So 8.8. That's my coefficient. So now I have to multiply it by 10 to some power. To determine what that power should be, look at where I'm now saying my decimal is going to be located. So I'm now saying my decimal is going to be between the two 8s. In order to get back to the original position, remember, if you don't see a decimal, that means that there's an imaginary or an implied decimal at the very end. So in order to get back to that very end, I would have to move to the right 2 places. So this is 1 place, 2 places to get back to that original position. Therefore, since I'm moving to the right, my exponent is going to be positive. Because I had to move to the right 2 places, it's going to be a positive 2. So we would report 876 as 8.8 times 10 to the 2 in order to show it in scientific notation containing only two significant figures. Then the last part. The last one, you're performing various calculations and you're reporting your answer based on the rules of significant figures. And so the first one, 9 times 20, if you were to put this in your calculator will give you 180. And so that's the product of 9 times 20. 180, as shown, has two significant figures. Check to see what your answer should have. You're multiplying, so you have to look at the number of significant figures in each measurement. We have 9, which only has one significant figure. We have 20. Based on how it's written, because there's no decimal, it also has one significant figure. Therefore, your answer should have only one significant figure. Right now, it has 2. So we have to round to one significant figure. The first significant figure is that 1. This is your hundredths place. So just imagine rounding 180 to the nearest hundred. If you had to round it to the nearest 100, we have to look at that next position, which is the 8. Based on that value of 8, I know that my hundredths place, that 1, has to round up. So therefore, I would report this as 200 to show the product of 9 times 20 with only one significant figure. So remember the rules for significant figures involving calculations. Multiplying and dividing, you have to look at the measurements that were used. Whichever had the least number of significant figures determines the number of significant figures you should report your answer with. For addition and subtraction, look at the number of decimal places. So how many digits after the decimal? Whichever measurement had the least number of decimal places determines how many decimal places your answer should be reported with. So these are the ways that you would approach the various sections of this worksheet. If you go to the final page of the worksheet, the answers for every problem are present.